Good afternoon and welcome. Reaction mechanism can be discussed in the following topics. First is the elementary classification. Second is the breaking and the making of the bonds. Third, reaction intermediate, types of reagent, thermodynamics of reaction, kinetics of reaction, stoichiometry of reactants and products, methods of determining the mechanism. Today, my discussion topics is reaction intermediate. Reaction intermediate are generated by the breaking of bonds, which are short-lived because their transient nature and highly reactive, and also discussed in following topics: carbon radical, carbonium ion, carbanions, carbenes, nitrines, benzene, bicomplex, sigma complex. Carbon radical, it is also called free radical. Carbon radicals are odd electron species in which carbon atom bears odd electron. In the initiation step, the covalent bond is dissociated equally one electron. It is dissociated into free radicals, and these free radicals are also attack another molecule to form propagation ends, and is the two free radical or carbon radical also form the another bond, the termination. In the formation of carbon radical, it forms by the breaking of homogeneous breaking, that is, these two electrons are dissociated equally the both sides, that is A and B. In this general example, carbanions are positively charged species in which carbon atom bears positive charge, those 6 bonded electrons. Also, we know carbocation. Carbanions are the negatively charged species which a carbon atom carries the 3 bonds and lone pair of electrons, making the negatively charged. This is the example of carbanions. Carbon with a negative charge. Carbenes are very short-lived species which one of the carbon atom possesses 2 bonds and 2 electrons, maybe paired or an unpaired, but it is not a lone pair. For example, this is the carbene, have the carbon hydrogen 2 bonds and 2 electrons. In this example, the addition reaction, halide formation, and insertion reaction takes place in the carbene. Nitrines is similar to carbene, but in nitrines, the similar condition in case of the nitrogen, nitrines are non-isosyllable, transitionally substantially reactive, and electron deficient species like carbene, but contrast carbene which have the 6 electron on a nitrogen atom. This is the example of the formation of nitrine. This is the nitrine. Sorry. Benzene is similar to the benzene, but having the one of the double bonds is replaced by the triple bonds. See, this is the benzene-like structure, but this double bond have the triple bond. The benzene is the benzene. Bicomplex is the weakly bonded charge transfer complex which exists in solution one layer, is formed by the association of electrophile species and electron donating species. This is one layer association which utilizes pi orbital electrons for association known as the pi complex. This is only association of electrophile species and electron donating species which utilize the pi electrons. Is the pi complex. This is the pi electrons which is associated with this electrophile. This is the pi complex. It is applied as the pi electrons for the association. This is another example of the pi complex. But in case of sigma complex, when electrophile reacts with arene, in case of the pi complex, only electrophiles it associated with electron donating species. In case of sigma complex, electrophile most reacts with the arene, usually in presence of the catalyst to produce salt. You may confuse here. In case of in above example, we have C in pi complex, and this is the pi complex, and electrophile they are not reacted, only sharing of the pi electrons with the electrophile. But in case of sigma complex, the most electrophile most reacts with arene and presence of catalyst to produce salt. The salt is composed of anion and complex carbon ion in which only two of the pi electrons are utilized to form sigma bond between the particular carbon atom of the ring and electrophile, which is called sigma complex. This is the sigma complex. This is the arene which is reacted with the electrophile and form sigma complex. Thanks for watching.